All right, welcome to class, everybody. Our lesson today is section 6.4, and I actually don't know what this topic is called. It's kind of a combination of everything we've learned so far. So I called it complex fractions. It's not like the technical term for it though. Because basically what we're looking at is how do we simplify expressions when you have fractions within fractions. So let's look at a semi-simple example to start with. So in this example, we have one big fraction, and in this big fraction, you have two fractions in the top and the bottom. So the way that you can simplify this is by remembering that a fraction can represent division. Like, for example, if we have like the fraction 1/2, you can think about that as a fraction 1/2, but you can also think about it as 1 divided into 2 pieces. Either way works. And in this case, it's going to be easier to think about it as this. So we'll look at this and we'll say, okay, well, this is the same thing as 2/3 divided by 3/5. And we learned 2 classes ago that we can we can divide fractions by multiplying in a zigzag pattern. So I could go 2 times 5 gives me 10, 3 times 3 gives me 9. And so the answer would be 10/9. This would be the simplified version of this expression. Everybody good with that? And if you don't like doing the zigzag method, you can always do the multiply by the reciprocal method if you like that better. So this general idea is what we're going to apply over and over and over in our homework. But we're going to apply it with fractions that are slightly more complicated. Like, for example, let's say that we had this. So in this one, we have one big fraction, but in the top of our fraction, we have 2 fractions that are subtracted. And then in the bottom, we have 2 fractions that are added together. So the first thing we want to do in order to simplify this is we want to make it so we just have 1 fraction in the top and 1 fraction in the bottom. Because once we have 1 fraction in the top and bottom, then we can use a similar strategy to what we did here. So to make 1 fraction in the top, I'm going to need to subtract those fractions together. And that means that I have to have common denominators. So the common denominator of 4 and 5 is 20. And the common denominator for 3 and 9 is 9. Is everybody good with that? And so then I just need to convert my fractions. So I'll say, well, 4 times 5 equals 20. So I'll multiply the top and the bottom by 5. To convert that fraction to 20ths. Then I'll multiply 5 times 4 to get 20. So this one is 4/20. Then 1/3, if I multiply that by 3/3, that gives me 3/9. And 1/9 is already a 9th, so I don't need to change that number at all. So then I can simplify this. On the top, I'll end up with 1/20. Because if I have 5/20 and I minus 4 of them, that gives me 1/20. On the bottom, I'll have 4/9. And now I have a single fraction divided by a single fraction. So I can rewrite this as 1/20 divided by 4/9, and then do the zigzag method. So 1 times 9 gives me 9. 20 times 4 gives me 80. And my answer would be 9/80. So the general strategy you're going to use on all of your homework problems is when you have a big complicated fraction like this, you first simplify the top by getting common denominators or doing whatever you have to do to make it so you just have a single fraction like we did here. And then you do the same thing in the bottom. And once you have a single fraction in the top and the bottom, then you can divide them. So let's look at some examples where we would have polynomials. So if we look at this one, actually, let's do one with variables. Yeah, let's do this one. Okay, so if we look at this one, we have one big fraction, but the top of the fraction and the bottom of the fraction have multiple parts. They're not just a single fraction. So we need to simplify the top and simplify the bottom so you just have a single fraction in the top and the bottom. So how would we do that in this case? Any ideas? So right now in the top, we have 2 fractions, right? We want to make it a single fraction. So that means we're going to subtract them together. What do we need to subtract fractions? Common denominator. And what would the common denominator of the top be?
It's YX.
Perfect. Yep. So we'll have XY or YX. It doesn't matter. It's the same thing. So that will be our common denominator in the top. We also need a common denominator in the bottom. What would that common denominator be? Yep, that will be XY as well. Okay, so now I say, okay, well, for this first fraction, if I want it to have a denominator of XY, I need to multiply by Y on the top and bottom, which gives me 3Y. If I want to have a common denominator of XY for this next one, I need to multiply by X. So I get 5X. And then for 1 over X, oops, I need to multiply by Y. So that will give me Y. And for this last one, I need to multiply by X. So that gives me 3X. Everybody good with that up to that point? Okay, so then we subtract these together. And if I have 3Y over XY minus 5X over XY, well, I don't know what Y and X are, so I can't necessarily combine these, but I can just write them as a single polynomial. So I'll have, oops, 3Y minus 5X, and that polynomial will be over the common denominator XY. So it's a single fraction. The fraction or the polynomial, excuse me, the fraction has a polynomial in the top. So it's kind of a complicated fraction, but it's still just a single fraction versus over here, we had 2 fractions. So that's the top part of my big fraction that I'm trying to simplify. Then the bottom part is going to have Y plus 3X. So I'll do Y plus 3X over XY. And now that I have a single fraction divided by another fraction, now I can divide them with the zigzag method or multiplying by the reciprocal. So divide by Y plus 3X over XY. When I do the zigzag method and multiply this times XY, I get XY times 3X minus 5, or sorry, 3Y minus 5X in the top. And then when I take this fraction and multiply by, or sorry, this polynomial and multiply it by this, in the bottom, I get XY times Y plus 3X. And that's what that would equal. So this is my answer. However, I can simplify my answer because I have X's in the top and the bottom and Y's in the top and the bottom. And everything's in factored form, which means that I can cancel those out. So I'll cancel those out. And that gives me 3Y minus 5X over Y plus 3X. And that would be my fully simplified answer. Any questions on that? Yeah.
Why can't you cancel out one?
Good question. So the only time that you can cancel things out is if things are multiplied. So an easier way to see this is like if you had the fraction 1 plus 2 over, I don't know, like 3 plus 2, you couldn't cancel out the 2's and say this equals 1/3, right? Because 1 plus 2 is 3 and 3 plus 2 is 5 and 3/5 doesn't equal 1/3. But if you have 1 times 2 over 3 times 2, you can reduce that and say it equals 1/3 because this is 2/6 and that equals 1/3. So we can cancel it out here because we have everything multiplied together. But in this case, they're being added. And so you can't cancel out more things. That's a really good question. Any other questions? Okay. Let's try this one. Okay, so on this one, what do you guys think our first step would be? Perfect. Yep. So we need to get common denominators in both the top and the bottom, because right now we have 3 different fractions in the top and 3 different fractions in the bottom. And before we can divide the top and the bottom, we have to have a single fraction. So in the top, what would our common denominator be for those 3 fractions? Yep, perfect. We'd have a squared as our common denominator. Because if we look at our original denominators, we have an a squared, an a, and then technically you could write 3 as 3 over 1. And the factors numbers that are in here, like we need a 1, but there's always a 1 in the common denominator. We need an a, which is covered by a squared, and we also need an a squared, which is also covered by a squared. So that would be our common denominator. And to make this first fraction have a denominator of a squared, I need to multiply the top and the bottom by 3, or excuse me, by a squared, which would give me 3a squared. Then for this next one, to make a become a squared, I need to multiply by a, and I'll do that on the top and the bottom. So that gives me 7a. And then for this one, the 6 is already over a squared, so I would just leave it like that. Then on the bottom, I also need common denominators there. What would be the common denominator for the bottom of my big fraction? Yep, that one's going to be a squared as well. So again, this 6 already has a common, or already has a denominator of a squared. The 3, which I could write as 3 over 1, needs to be multiplied by a squared. And so that gives me 3a squared. And the 11 needs to be multiplied by an a to make a denominator of a squared. So now that I have common denominators for all of my fractions, now I can combine them together and add them up. So the top of my fraction is going to look like 3a squared plus 7a minus 6. And that is all over the common denominator a squared. And then on the bottom of my fraction, I'm going to have 3a squared minus 11a plus 6. And that's over a squared. So now I have a single fraction divided by another fraction, so I can do the reciprocal thing. But before I do that, I should actually probably get these into factored form because it looks like those can be factored. So let's factor the blue one. If we do negative 6 times 3a squared, we get negative 18a squared. What are two things that multiply to 18 and add to 7? Or negative 18, I should say. The negative is important. Yep. So I'll have 9 and 2. And I think the 2 has to be negative, and the 9 will be positive. Yeah, because that will add to a positive 7, but multiply to negative 18. So I'll split those up. Gives me 3a squared. Split into two groups. My first group has a 3 and an a in common, which leaves me with a plus 3. My second group has a negative 2 in common, which leaves a plus 3. And so I get a plus 3 times 3a minus 2. And so, well, I'll use that in just a second. So we'll just hold on to that for right now. Then I'm also going to factor this. So if I do 3a squared times 6, I get positive 18a squared. And what are two things that multiply to positive 18 but add to negative 11? 9 and 2. And would they be positive or negative? Yep, they both be negative. So I'm going to get 3a squared minus 9a minus 2a plus 6. Split those into two groups. You get 3a in common, which leaves a minus 3. And negative 2 in common, which also leaves a minus 3. So I have a minus 3 times 3a minus 2. So these are the factored versions of these two polynomials. So now I can write this out with division. So I'm going to say this is going to equal my blue polynomial, a plus 3 times 3a minus 2 over a squared. And I feel like it actually might be easier to think about this as multiplying by the reciprocal because I don't have to write out the whole zigzag thing. So I'm going to write it this way this time. So the reciprocal of this would be a squared over a minus 3 and 3a minus 2. And in this case, when you multiply those two together, the a squareds will cancel out. And I believe also the 3a minus 2s will cancel out. And so your fully simplified answer will be a plus 3 over a minus 3. And I guess you don't actually have to write the parentheses because there's no other factors. If there were other factors, so you would have to write the parentheses. Are you guys good with this? Because I was using the zigzag method and then I like switched to the reciprocal method, but does that make sense? Okay, cool. So again, general strategy, you do whatever you need to do. Usually it's finding common denominators, make it so that the top and bottom of the fraction are a single fraction. Then you do this division either with zigzag or multiply by the reciprocal to get your simplified answer. Now on your homework, you'll have a couple problems like this one. So on this one, you have something subtracting a complicated fraction. So what you want to do here is whoops, accidentally touched it. What you want to do here is you want to simplify this fraction as much as you can, and then you'll find common denominators with this and your simplified version of this. So what would you guys do to simplify the complicated fraction? What would be your first step? Perfect. Yep. So I'm going to write out my whole expression still because I don't want to forget about this y minus thing. But I'm not going to do anything with it for right now. So I'm going to do y minus 1 over, and then you said find a common denominator with the 1/5. What would that common denominator be? Yep, just a 5. So the 1/5 already has a denominator of 5. To make y have a denominator of 5, you would multiply by 5 over 5, which would give you 5y. And so that means this is going to equal y minus my big fraction. And in my big fraction, 5y minus 1 is going to give me 5y minus 1 all over 5. Now, if I do 1 divided by this, I can think about this as being, maybe I'll like write this out on the side. So I'm going to write this out as 1 divided by 5y minus 1 over 5. Well, 1 is 1 over 1. And if I do the zigzag method, I'm going to get a 5 on the top and a 5y minus 1 on the bottom. So this complicated fraction here ends up simplifying to this. Everybody good with that? Okay, so that means this is going to equal y minus 5 over 5y minus 1. Now this is still not simplified though, because now I have this minus a fraction, but I could simplify it further by getting a common denominator between this and this. And that common denominator will be 5y minus 1. So I'll write this out as 5y minus 1 minus my other fraction. Now this fraction will stay the same, but to get y to have a denominator of this, I need to multiply by 5y minus 1 on the top and on the bottom. And so that's going to give me, when I do y times 5y, that gives me 5y squared. When I do y times -1, that gives me -y. Is everybody good with that? Okay, so then we combine those together and we say, well, this stuff minus 5, since there's no like terms, because this is a y squared, this is a y, and this is a constant, I'd just write it all out and I'd have 5y squared minus y minus 5 over 5y minus 1. And so then this is my final answer, but I have to see if I can simplify it. So because this is a trinomial, I'd say, well, 5y squared times -5 is -25y squared. There's not anything that multiplies to -25 and adds to -1. And so I can't factor that. But if I could factor it, I would want to do that because it's possible it might be able to cancel out this factor on the bottom. But in this case, it doesn't. So you could just leave it like that. But you always want to check and see if it is factorable to simplify your answer. All right. Any questions so far? Okay, let's do a check-in. So scale of 1 to 5. How are you guys feeling about these complex fractions? Okay, cool. So on your homework, you're basically just going to see lots of different versions of this. So in general, simplify your most complicated fraction by making a single fraction in the top, single fraction in the bottom, and then dividing them. So you'll have some like this one where it already has a single fraction and a single fraction. So this is pretty easy because you don't have to find common denominators or anything. But you will still need to factor this because it's a difference of squares, and factor this and cancel out any like terms. But you'll get some like that. And then you'll have some like these ones where you need to find the common denominators before you'll be able to do the factoring. So I'll let you guys start working on your homework. And if you run into any questions where you're like, I'm not sure where to start on this, just let me know, because the principles are pretty basic, but sometimes knowing which principle to apply in which situation can be a little bit more hard. So let me know if you guys have any questions. Yeah. Okay, yeah, so the way that you would do this, because you can't combine any of these terms, right? Like they're all different. And there's 4 terms. So the way you would factor it is by splitting it into 2 groups. And the first one has an A in common, so you get A times C minus 1. And then in this one, they don't have anything in common, so we can say that they have a positive 1 in common. Because like, you know, if you divide C by 1, it's still just C. And so you get C minus 1 there as well, which means that that top part of the fraction is when you factor A plus 1 times C minus 1. And then this bottom one will be very similar, except just because the minus is coming, it would be A plus 1 and C plus 1. And in that case, the A plus 1s will cancel. But these won't cancel because they're not the same. And so that would be your answer. Thank you.